what I mostly want to go over in these 2 days is just a broad knowledge of QOGI, an introduction to the actual tablet itself, a little bit of history of that so that you can understand where it came from, its foundations, how it works, a review of the optical gas imaging fundamentals. And as I mentioned, I kind of want to lean a little bit on the more basic side of how a clock works today. An introduction to the QOGI method, where we get into a little bit more in-depth theory, and then learning the QL320. That's what I would define, that 360-degree view of the software and the tablet itself, what all it does, and make sure that when you walk away from here, from this meeting, this GoToMeeting, I want you to be able to walk away and say, you know what, I understand this enough. I'm comfortable to be able to use this, and more specifically, there's nothing hidden within the QL320 that Craig didn't try to introduce to me, and I'll try to make sure that happens. One of the key takeaways as we've been selling this QL320 in various markets are the tips and tricks, the ability for users to see the QL320 challenges and the little basic things that help using the QL320. We're working with marketing and in a bit of a holding pattern, putting together some marketing collateral, but I do have some presentations or a presentation on the top 5 tips and tricks that I can share with anybody after this. This presentation will also be shared for internal FLIR consumption, and I will allow the FLIR sales managers to use that as they see fit. One of the things on understanding the value of a QOGI and QL320 to our customers is understanding the method limits, the performance. In other words, talk to you about some public research that we have done, stuff that you can point our customers to show them the performance and how well the QL320 has operated in some cases compared to the industry leading quantification tools that may have been in the market for 20 and even 30 years. As I mentioned, the first thing, I want to just introduce you to the QL320 and the basics of this technology and the basics of what's happening within the QL320. As I mentioned on the basic front, the QOGI technology, it allows us to use our legacy optical gas imaging technology. Now, I will admit, have to state that limits it to any of the optical gas imaging technology that A, sees hydrocarbons, and B, is radiometric or can measure temperature. So that limits this to the GF320, the GFX320, and the GF620 in our portfolio. So it does have to measure temperature, and it is only for our hydrocarbon versions. But in essence, that algorithm that you see right there is not just a bunch of numbers and letters. That is the actual algorithm that Providence Photonics, who is our partner in this venture, that is the actual algorithm that the QL320 uses inside of it to be able to quantify the leaks. Now, I will state it, there's a lot going on inside there, and there's a number of variables built into that algorithm, but that's actually what is happening inside the camera. The delta I there is the change in intensity at a pixel level as that pixel moves across your screen. But the biggest reason or the biggest thought is, why would you want to use a QL320? Why would you want to use QOGI? The number one reason, if we look at this compared to other technologies, is this definition of see the leak, measure the leak. The other technologies that are out there give you the capability to measure a leak. But as you can see in this screen, if you don't happen to hit the leak where you're supposed to, you're flying blind. You're using a technology that doesn't allow you to see what it is that you're trying to measure. So you're just hoping that you actually happen to stick the device, in this case a TVA or sniffer, in the plume at the precise location where the plume is originating and where the maximum leak detection level of that plume might be. Again, that's really challenging if you're able to, if you have to kind of think about the capabilities of just blindly measuring emissions. There's also a safety factor here. With optical gas imaging and QOGI, you have the capability to do this without being in the plume in your own, in your own safety, capabilities. Within the industry, you're going to hear the letters DTM, in particular in the United States regulatory framework. They talk a lot of DTM, and what that means is difficult to measure components. In a regulatory framework, there is no requirement, or there is an exemption with DTM components, so that you do not have to measure these components that might be at a great distance away. Some of them you may be able to build scaffolding, and if you can imagine the amount of time and effort it takes to build a scaffolding just so that I can go measure this component, it would be very, very challenging. The reality is I've had some customers do some work where they do an analysis of how many emissions are created by 2 to 4 people driving to a facility for 4 days to build scaffolding, and the amount of carbon dioxide equivalent emissions that are created just to build that scaffolding generally are more than the emissions that they're finding within that facility. Being able to use OGI and QOGI allows you to not only see those emissions, but now you can use the technology within the quantification of optical gas imaging to at a safe distance and at a distance that cannot be used with other technologies to be able to actually measure those components. And lastly, a QOGI advantage is the comparison to other technologies. There's a few studies that the company that we work with to develop this technology has done a fair amount of things, a fair amount of studies. Unfortunately, a number of those studies are internal and private. They're able to present on this, but they do not have names involved. One of the 2 studies that are public that have a large name involved is a study through a company called QOGI. And what they did is they tested the QOGI technology in its infancy stage. This was well before the technology has made its advancements to where it is today. And they tested that against a toxic vapor analyzer or a TBA or a sniffer. The result of that is that the QOGI technology was approximately 6 times better at accuracy in measuring the components that were leaking. Now, if you think about this, it wasn't just 6 times better compared to the way somebody would normally use a TBA or sniffer. This was 6 times better, and the sniffer had the advantage of an OGI camera telling it where to go measure. So extremely advantageous as far as a comparison report to be able to show it against other technologies that are in the market. So what is the FLIR QL320? Again, as I mentioned, it works with our hydrocarbon radiometric cameras in the GF320, X320, 620, and it contains that really unique algorithm that I showed you in being able to quantify optical gas imaging. There are 3 different methods that it can quantify. It will quantify in a mass emission rate. That's going to be a grams, pounds, or tons. When you start looking at a weighted mass of a emission, it can actually do those calculations internally. It can also measure in a volumetric emission rate, and that's going to be those standard cubic centimeters, liters, cubic feet for those of you in the English system, which is standard cubic feet per hour or per minute is one of the most common ways in the US that we measure. But one of the new features is a concentration measurement. The world has always accepted a concentration, which a challenge of a concentration is it is a measurement at an individual location. not as something changes from one location to the next. When you use a sniffer, you are measuring exactly where the input of that sniffer is only. And that doesn't truly tell you what's happening as a leak is moving. That just simply tells you a concentration in that area. And we can actually measure a concentration over a 1 meter distance. And it's an average of how the intensity of that pixel over that 1 meter distance. And a parts per million meter in other technologies is becoming more and more accepted within the various industries that we operate in and the various entities that are utilizing a quantification solution. We'll get into it a little bit more, but there are two ways to use the QL320. The first is tethered, in other words, where you actually have a USB cable tethered to the QL320 and directly to your camera. GF320, obviously you can use the X320 or the 620. There are some advantages in that, and we'll talk a little bit about those, but it does require a little bit more cumbersome use while you're in the field because you're tethering in, and you cannot use this device in a Class 1 Division 2 or a Zone 2 location. But because we realize the need for people to go out there, they might need to use this in a hazardous compliant location, and they might want to use this in a scenario where they just don't want to carry around a tablet. We invented a Q mode feature, which is most of what the customers that I see using this camera, allowing you to store in the field an actual file or a video that helps understand or that helps you bring that individual file into the QL320 for post-processing at a comfortable location. In the evolution of the QL320, just to help provide you with a little history, the first solution was in January of 2016 with our partner Providence Photonics. It was the yellow version of their solution, and really it really introduced the world to quantification within optical gas imaging spectrum. In 2017, I worked with the Providence team, and we really advanced their solution quickly to meet the needs better of the market and of our customer base. We aligned their solution, both nomenclature and look and feel, with the way that FLIR would probably envision the solution. And then in 2019, we entered into a minority share agreement with Providence Photonics, in which now the unit is fully FLIR with the engineering from Providence inside the unit. We added some unique features, a completely new graphical user interface, as well as adding our concentration measurement. And very simply, what does it do? You need to put in some parameters within the variables that may affect OGI. You need to understand and understand the ambient air condition, ambient air temperature. What gas in primary, understanding that often gases may travel in combination. And so what gas primarily is in the stream that you're looking at. You'll need to understand the distance to your location. The optics are self input by the QL320 itself. A basic wind speed, and it does begin, and with all of those parameters, it begins telling you an exit velocity of your solution. It allows the user to perform standard measurements and allows it to be used in a variety of conditions. When you're using this, there are really a few things that you need to have. First off, you've got to have an OGI camera from FLIR. This camera does have to be tripod mounted. The solution is watching pixels change across a screen. And if you can think of using your QL320 technology, those pixels changing across the screen may not work as well if your system is not steady. So you do have to use the tripod, whether you're using this on tethered mode or Q mode. You do need a USB cable if you're using the solution in tethered mode. And the three devices on the bottom are going to be the anemometer and the thermal anemometer to get ambient air temperature and an estimation of wind speed, and a distance measurement. The distance measurement to understand how far you are away from the component that's leaking. These are all inputs that you would put either in the Q mode feature or in the actual QL320, or in the QL320 while it's tethered to the solution. What can you measure? What are the things that you can measure? Obviously, we talked about delta T. These are inputs that you'd put in. Point sources is what you're going to utilize most anything. That you can do a diffuse source, which is something with over a 12-inch or 1 foot. Apologize for those that may do more metric, but an area where there's a large leak outside, maybe like a seal on a tank. Often this is going to be used for leak detection repair. You can use it for tanks and pneumatics, compressors, valves, fittings, all kinds of different solutions and all kinds of different applications that you're going to have. All right, well, we'll go ahead and jump into session 2 here, TP, and then if there's other questions after that, we can get to that. How does optical gas imaging work? I don't want to get too much into this, but for those of you that may be new to the technology, simply put, an infrared camera, an optical gas imager, has energy from a background that is actually going into the camera itself. The majority of the time, unless you're looking at the sky, anything else that actually has energy in it, that's not negative energy, that energy is moving from whatever it is into the camera. At times, you may run into a scenario where there is a leak in between that background of energy that you're looking at and the camera. And what happens is that gas leak actually absorbs the energy before it can get to the camera. And that almost creates a negative image, and that's where the smoke-like image is portrayed, because we're blocking that energy from getting into the camera. We'll get into that a little bit more when we talk about QOGI technology, but that's the most basic way to understand OGI. For those of you that may not be aware, how we can see this, very simple, is we actually match a spectral response of the optical gas imaging solution, or our cameras, to the peak spectral absorption of the gas. In other words, we filter the camera in alignment to the infrared absorption of the gases we're looking at. Hydrocarbon gases, they generally, almost all of them have some absorption from 3.2 to 3.4 micron, and that's where our filter and our hydrocarbon cooled solutions lie. And how do you tune these? As we mentioned, we do this through filtering. And so if you look at the actual solution, you have energy that comes through the lens, and it hits that gray filter right there. And when it hits that filter, it limits that energy that gets to the detector. What is unique about our solution from our cameras is that this filter is built inside of this cold shield. You have the dotted line that is the camera body, but you have this angular line, this area that is a cold shield. And so the energy is coming into this, the detecting filter is built into that, which maximizes the sensitivity of the camera and the ability for it to sense, to be able to detect and visualize emissions. There are two different ways. As I showed you a minute ago, what happens is when the gas gets between the background, and there are two different scenarios in that. The majority of the time they use this camera, in particular in the downstream market, you're going to have what we define as a black cloud or an absorptive plume. Again, you can think about it as the background, whatever is from the background. A minute ago, it was that plant, but the background energy is sending energy, and this cloud is absorbing or absorptive The cloud is absorbing the energy and not letting it get to the detector. In contrast, when you do see a white cloud, you're going to run into a very similar scenario, except for that cloud is actually emitting energy. So we're seeing the gas rather than the background. So the energy from the lack of energy from the background, because when you look in the sky as an example, the lack of energy from that background is very, very challenging. And so what's happening in this case, the plume is white because it is emitting that energy to the camera. These are two examples of a absorptive plume. And how do you know one? It's very simple. It's defined as a black cloud within the QL320. But what's happening here is the apparent temperature in the background. What's happening behind the leak is higher than the plume temperature, and that plume temperature is the ambient air temperature where that leak is happening. Again, that background temperature, the temperature behind the system and that you would see in your camera, is higher than the temperature of the ambient air around where the leak is coming up. In the cases where there's a white plume, in the majority of the cases that you would run into a white plume, it is going to be with the sky background. There may be scenarios, we have customers in the colder environments where you may have a leak in a facility and you have a snow as a background, as an example. That is another case where you may have an emissive plume. But in this case, the ambient temperature in the background is lower than the ambient air temperature around where that is, or the actual temperature of the background is lower than the ambient air temperature of where the plume might be. I'll get into the introduction of QOGI, and then we'll take some questions after that, if that's all right, TP. But we're looking at that what is QOGI? And this is a really interesting statement. And I guess, Chris, we should have tried to put this into a poll, but can you tell me which leak is higher? Looking at these two videos, and I'm trying to understand what's happening, the majority of people that I go to whenever I talk at trade shows considerably say that the leak on the right has to be higher. It's a deeper black, it's a heavier looking plume, and that these leaks have to be higher. But if we look at the actual numbers of what these leaks are, both of these leaks are the exact same. They're both about a half a pound an hour in a leak. So why would they look so different? For those of you that are, have been around OGI or even infrared for a while, they're actually changing the dynamic range. They're changing simply the level and the span. But this is just to show that sometimes what you see may not have as much value as the reading that you have. They're changing that temperature range setting within the camera, and they're changing the way that it's displayed. Now, we can't use the various temperature ranges in the manual with the camera. So when you're utilizing a QOGI solution, I believe that the camera will lock into the auto plume, and that auto plume is what is the way that the QL320 calculates that delta I, or that change in intensity from one pixel to the next, and how much that intensity changes compared to the background that may not be getting into the detector. There are three factors that are very important. Some people might call these the QOGI triangle, which we'll get into. But the three main factors are going to be the delta T. Understanding that you need to have a delta T to be able to visualize optical gas imaging and be able to visualize a gas, and with QOGI to be able to actually quantify it. Now, if you look at this in the video on the left, you'll notice that we can easily see that same leak that we were looking at a minute ago. But as it begins to get over this background, you can begin to see it only because of the fence. If there wasn't a chain link fence right there, it would be extremely challenging to be able to see that. And that simply has to do with the delta T between the background and what you're looking at not having a minimum of a 2 degrees Celsius delta T from A to B. You'll also, the other factor that heavily affects OGI is the response factor. In other words, the intensity of that gas and how well it absorbs energy in the filtered area of the camera. Propane is considered the rule of thumb in the US. We talked about that. It's standard gas. So with propane, it has a response factor of 1.0. Some may have a higher response factor. Methane, as an example, has a smaller response factor at 0.3 almost. Now you'll notice these images that you see in the middle, the two videos right here in the middle, those are the exact same leak. It's the same size leak, but because propane has a higher response factor, it's approximately 3 times darker in viewing. Again, what you see may not have the true implications as to the quantification of that gas. And there are a number of factors. The last one is very simple. There must be gas present. The more gas that's present within the same response factor, the more you're going to be able to see and the more that you would measure. The QO320 operates in 2 different modes. The first one is measuring volume or mass. In the volume or mass mode, what you're doing is you're extracting that plume from the background. You just tell the tablet itself, is this a black or a white cloud? Is this an emissive or is this an absorptive plume? As you're extracting that background information in the cloud, what's happening, you're gonna have what they define as the path length measurement. That is from the center of the circle as it's moving out, and it is calculating as all of these pixels are changing in time, and they're correcting for the change in temperature, the response factor of the gas that you input, the distance that you've set within the device, and it's trying to understand the exit velocity of the gas here as it crosses that boundary. Using the volume or mass, if the leak never leaves the blue circle, it will actually never measure that. So if it were to what is defined as pooling inside there. So that's why a little bit, a very minimal amount of wind is probably the most ideal situation. Maybe not extremely high winds. And again, when it looks at that signal, as you can see, the signal changed by the colorized areas of this. When it looks at that signal through its formula, it will give you these various curves, and I won't get into the technical aspect of that, but the various, the linear calibration curves of each individual pixel as it's moving from the center of this to the outside. The newer way for us to calculate, quantify optical gas imaging is through concentration. And this is doing a parts per million, or ppm, over an estimated 1 meter. And when we say 1 meter, it's not meter from left to right or right to left, top to bottom or bottom to top. It's assuming that that leak is 1 meter in the 3rd dimension. In other words, if we could see straight through this video looking away from the screen that we're looking at, it's assuming that that leak has a 1 meter thickness from the Z dimension, or the 3rd dimension that we can't see in a 2-dimensional video. With that, we're calculating only the delta T intensity and the response factor. Now you'll notice there's a lot there's a lot more simplified delta I, or the change in intensity calculations, doing this with parts per million meter, is it's only calculating this. You'll also notice that there's not a center point and a circle. This box is nothing more than a reference, and the reference of this box is calculating within that box the individual location that has the maximum concentration reading. It would, in this case, it would probably be right around here. So you can use the box to block out any potential foreign objects or any scenarios where you may have something that may affect the reading. The reality is, if I were to take this box and make it about 10 times smaller and only put it right here on the corner of this controller, the box would give me the exact same reading. If I were to take the box and make it considerably larger, the reading that the box would give me would be from this hanging string from the key that's used to open this controller. You can see the yellow right here, and that's going to be the maximum intensity of this video consistently. And so that would be a very errant reading, which we'll get into when we talk a little bit about the tips and tricks of using the QL320. So the next thing we'll get into is actually learning the tablet itself, and learning how it operates, what it looks like. And again, my goal here is to tell you as much as I can, and I'll explain to you what I can't teach you today. But my goal is here to teach you everything that this uses. If you use 10% of it, then great. If you use 90% of what I tell you, then very good. But my goal here is to make sure that you understand the actual technology that we're looking at, and that you understand how to use the camera and the tablet as efficiently as possible. As I mentioned, there's two ways to use this. Tethered when connecting to the camera. That will again be a USB mode, even though I have a GFX 320 in using this. The GFX 320 is a Zone 2 compliant device. The QL320 is actually a Zone 2 compliant device, although when you open either unit up to expose a USB connection, you actually remove that Zone 2 compliance from either the QL320 or the tablet itself. So, I want to make sure that you understand that doing this. Understanding that need, our FLIR engineers developed an internal communication software called Q mode. And Q mode gives you the ability to input the necessary parameters that would match what needs to be used when live and tethered with the QL320. That allows you to use it in a unique Zone 2 location. It also provides a couple of things. For us FLIR sales guys, if you have some customers that may have a GF320 or GF620 or a GFX320 that may have Q mode, you can have those customers understand the limitations, like using the camera on a tripod, but you could actually have that customer send you a video and you could be able to quantify it from your office. They would send you the SEQ file from Q mode, and you could quantify it on your QL320. You could also have customers that streamline the use of a QL320 and maybe have a single user that has a QL320 and others that may have Q mode. I will admit that that may take time and effort as you're using the QL320, because you have to run each individual file. But as FLIR salespeople, this gives us the capabilities to potentially introduce this to our customers and allow them to understand what quantification looks like. And it would probably require a minimal basic understanding of how to use the unit in the field. When I say the unit, how to use the camera, even if you're using the Q mode, which we'll get into that with our tips and tricks. The learning objectives of the QL3 is the tablet features. I want to make sure everybody understands that we have an easily acceptable quick start guide, some user interface, utilizing the Q mode, the campaign mode, and also understanding that we have a lot of these features available now at FLIR.com in English-speaking videos, and we'll get to that as well within this presentation. So if I'm looking at the tablet, I'm going to start with the left there with the number 1 and 2. It's very simple. You've got a power and a brightness, similar to what you're going to have on your iPhone or your Android. You can turn the screen brighter or dimmer. You have that capability. The 3 is called a quick launch button. There's really no functionality for us within FLIR to have much of a quick launch button because the tablet itself has the QL320 or the QOGI, the FLIR QL320 on the desktop. So there's not much functionality, but for some people that may expand the use of the tablet with other pieces of their business, you do have that capability. The Windows Start button is the same as you would have on your computer. And the camera launch button on the top right, number 7, is again disabled because we don't have any applications with the FLIR QL320 where we would need to launch the actual camera. If you do have a office or vehicle dock, which we do not provide with the QL320 and this tablet, it does have that capability. And then the charging port, there's a number of plugs on the bottom. Most of them are screws. Actually, they look like plugs, but the charging port is easily accessible on the bottom. As we look through 8 through 11, those are going to be your SIM card, your SD card, your USB, and your headphone jack, the input devices. And on the back of the QL320 system, you will have a battery lock or release latch so that you would have that. You're going to be able to use the QL320 for multiple hours with a single battery charge. But if you did have multiple batteries, that's how you would remove the battery with the QL320. We do have a quick start guide, and as I mentioned, the Q mode feature is going to be a streamlined version of the quick start guide. But we have a quick start guide that's available, and for those of you that may not know, it's as simple as typing in quickstart.ql320.com. And this will take you to a multi-page PDF that you can print. You can put it into your tablet or your camera case so that you have an always accessible. It goes everything, understanding how to ensure you have the correct firmware, what needs to be in the camera, and where to go look for that firmware, how to configure the camera up. And you'll see a number of mentions of ensuring that you're using the camera on a tripod, connecting the USB cable, launching the app itself, which we'll show you when we get into some live training, and then adding a lot of that user data that's necessary, and then how to save that data with the capture button. As we look at learning the QL320 and what everything is, the first thing are the user inputs that you'll look at when you grab the QL320 on the top left of the screen. These are the manual inputs. From polarity is very simple. What color is the plume? Sometimes you may need to turn the overlay off. I'll show you what that is here in a second to understand the color of the plume. But what color are you seeing? And rather than calling this an emissive plume and an absorptive plume and trying to make sure people understand, we've simplified this and said, what color plume do you see? If it says black plume and you see a black plume, you're in the right place. There are multiple leak types, point and diffused. I would say 95 to 99% of the time, your leaks or the OGI leaks that we would use with this technology are going to be a point leak. And even a leak coming out of a vent stack would still be considered a point, although that point is larger than other areas, unless that vent stack or that pipe is over 12 inches in diameter. The lens is a feature that we automatically integrate. So the QL320 will reach out to your camera and it will pull that lens data in automatically without any manual input. You do need to put in the distance. You need to be fairly accurate. Whether you would use a range finder like you would see a golfer use, a tape measure, or try to be as accurate as you can with a laser distance meter measurement tool, or even stepping off, you would want to be as accurate as you can with that distance measurement. But even more important is the accuracy within the temperature. That temperature is the ambient air condition around where the leak is. In other words, if you were to take an anemometer that you have within there, you would want to know the air condition. So if you're standing indoors but looking outdoors, and you're in an air-conditioned doorway, it's not where you're standing. It's where the leaking component is. It's not the temperature of the component. It is not the temperature. If you have a warm valve, it's not the temperature of the valve. It's the temperature of the air near where that valve is. The reason for that is that gases adapt to their environment very quickly thermally. So as the gas comes out of it may even be a warm gas comes out of a warm valve, physics states that that gas will adapt thermally to that environment in a very, very short amount of time. You will need to put the primary composition. As I mentioned, there are times where you may have multiple compositions, where you may have multiple. A lot of times your end users, your customers, will know what's in that pipe. They'll know how much percentage of things or what mostly that is. And so you would want to put the primary composition in there. And again, we do have the capabilities to be able to post-process the data with multi-composition if you need extremely accurate data. The reality is a lot of the response factors may be similar. As I showed you earlier, propane and methane are pretty different. Methane has a lot less response factor than propane, but there may be a lot of gases like butane or other gases that have a similar response factor within that same, a similar response factor, even though they are various gases. Sorry, the last thing is the wind speed. You'll notice that you don't have to be exact with the wind speed. You just need to give it an estimate. Is it a calm from just a little bit of wind, 0 to 1 miles per hour? Is it a normal wind from 2 to 10 miles per hour, or is it a high wind? This doesn't have to be overly accurate just to be able to, be able to gauge what you would consider a very calm day, a normal wind day, or an extremely windy day. Campaign is a place where the definition of a campaign is also a folder in the QL320. You can tell it where you want to store the data that you're storing. In particular, this comes into play when you're tethered rather than your Q mode, when you already have the data on a thumb drive or an SD card. And then the memo is the ability within the QL320 to type a memo and understanding and descriptive effort of what you're looking at. There are masking features which we'll get into, and that allows you to eliminate, in particular, even though this is the black box instead of the blue circle, in particular on the blue circle when you're doing mass and volume, it allows you to eliminate areas that may present error, which we'll get into when we start talking about and going through training on the QL320 itself. There are 3 overlays. There's a delta T overlay, which is the red in the background. The only delta T that's activated is right here on the left of inside of the square. There's a plume overlay. In other words, do we want this in black and white, or would we like a colorized plume overlay? And then the last one is a boundary, and that is only applicable when you have the blue circle using mass or a volume measurement. The units are the standard units that would you use, metric, English or metric units for distance as well as temperature. And then what units of measurement would you want to see output with your QL320? Mass, volume, grams, or cubic centimeters, or would you want to see that concentration reading? The three modes that you're going to have are going to be load, which load is how you would tell the QL320 to go find a Q mode file, to put it into the QL320 software, and to begin processing that file. There are two modes called normal and expert mode that you would use more when tethered. If you're tethered, there are some scholarly people that would like to have more data. The way that the QL320 works in normal mode is it pulls out approximately a 10-second file and tells you the quantification number from that file. We have learned over the years that 90 to 95% of our customers are mostly just concerned with a reading. They need to know a quantification reading in that 10 seconds. Because what we're doing is dynamic. What I mean by that is a leak is always changing. As I play any one of these videos, there is no consistency in the way a leak looks from the beginning to the end of any video. The leak is always dynamic. The more data that you can store over time, the more accurate the technology can be. We have multiple studies being done that have been done, and we have done one internally, which I'll talk about probably tomorrow, that as what's defined as aggregate data, in other words, as you use the QL320 in averaging a lot of data over time, the more accurate this technology gets. On an individual pixel, a 1 frame, a 1 second, or a single reading, the QL320 is less accurate. But as maybe a customer uses it within their facility, or maybe within a month or a week, if they're using it off of 1 or 2 readings, the QL320 on individual can be a little less accurate. But as they begin formulating an aggregate data set, it becomes more accurate. And lastly, with the demo mode is a great tool that I'll use today or tomorrow to be able to show people how to use the QL320, what it looks like, and you can use preset demo video files and use that in the normal mode and walk through all of these parameters as you'll see me do and explain how they affect. There is a manual and auto sensitivity. In general, the QL320 will choose what it feels as though is the best sensitivity in the scene that it's looking at. You might define this similar to high sensitivity mode for those of you that are familiar with our optical gas imaging cameras. And we'll show you a quick video on what that looks like and how that changes. If you're overly sensitive, sometimes you're going to see too much noise in the image. And if you're not sensitive enough, you may miss the leak entirely. Generally, I believe it stays at about 7 to 8 as its chosen auto sensitivity. There are the measure, reset, and rerun buttons. Those are going to be when you would use this to pull the data out if you're tethered in, or if you're using a Q mode file and you've changed some parameters, you may want to rerun the file. The results tab, you'll notice no results in normal mode. There are no numbers shown until the results bar reaches 100%. Makes it simple, easy, and it makes you understand. You wait for 100% and you're given an answer. And then underneath, you'll have some very basic understanding of what's happening recently with yours. This video file, I'm running this in parts per million meters, and I'm running sequence file 0258. This file has not processed yet, but the previous file that I ran was a different sequence file, 0157, and it ran and found approximately 12,000 standard cubic centimeters per minute in its leak. So you can see the last couple of the commands that you've done within the QL320. To get into some of the unique features specifically, this is going to be your delta T compensation. you'll notice the red background is right here within this. I'll show you in the tablet itself, this exact video, but you'll notice the red background. What that means is when the QL320 begins calculating the quantification of the video or the scene that it's looking at, it will exclude any pixels associated with a red background area, because it knows that there is not a minimum of 2 degrees C delta T to calculate that quantification number correctly. The colorized plume overlay, the second one down, is very simple. It's just a plume. It would be a black plume or a white plume, and it exchanges that for a colorization plume. And this would be an isoclef colorized plume, with yellow being the highest intensity and blue being the least intensity with the leak. And then you have the boundary. You have the capabilities to have the big blue circle. In this case, you'll notice that I not only have the boundary, but I actually have a mask turned on, and I've asked this to eliminate this area to this area. In other words, anything that may happen here, if there's any reflectivity or any challenges of what's happening on the piping itself, I want this quantification sequence to exclude anything outside of that area of the boundary of the circle. To do this on the QL320 itself, you would simply take your finger and you would swipe counterclockwise, 1, 2. In other words, start, finish. And then if you wanted to add, you could do multiple masks, which I think we'll get into here in a little bit, where I would swipe once, on, off, and then I would add a mask. I would swipe 1, 2 again, add a mask, 3, 4, add a mask, 5, 6. In this case, you have a pipe as well as an angle iron in between what you're looking at. And you can see some interference here with reflectivity off of this pipe. And the technology is looking at that and thinking that something is unique just because of the way that that's changing. And so you can use this multiple masks to be able to mask out any foreign objects or any stationary foreign objects that wouldn't be moved as the camera is sitting on a tripod. This is auto plume sensitivity from 1. You'll see this going up. You'll start to see 5, 6, 7, 8, and when it gets to 9 and 10, there's really too much sensitivity here, and it's making it a challenge for the technology. So for those people that need the most accurate, accurate, and they're tethered with the cameras, is a huge advantage of using the QL320 tethered versus manual, where you can change it Q mode, but this helps while you're in the field to understand what's happening. In this case, you would play with that. Generally, the leak is going to be at around 7 to 8. Very similar to those people that use high sensitivity mode, use it at number 2 almost exclusively in the research that we've done. When you're using the Q mode, huge advantage here is you can record the sequence. It's a regular specialized sequence file that we would have on the camera. You can transfer that very simply with a SD card. You can, if you had an SD card adapter in the camera and a micro SD card in that adapter, the QL320 will take an actual micro SD card directly in from the camera. You don't have to take the tablet into the field. You can process it in the truck when you're done with this site location's leaks, or you can process it in your office when you're done for the day. But the one huge key is make sure that your customers record accurate user data, the delta T, the distance. Make sure that they actually accurately input those manual inputs of data. Where do you do that on Q mode? You'll see I need to tell this is a black plume. or a white plume. I need to tell it the ambient temperature. What in degrees Celsius is the ambient temperature of the location where that plume is coming out of its component? The distance from the camera, the primary gas, the leak type, point or diffused. Again, 95% of the time you will use a point. And then the wind speed. Is this calm? Is it normal? Or is it a high wind speed? This will look almost identical to your QL320 with a little bit of order changed up. And this is just a little bit thing. One note here is that the lens is automatically input into your camera. So you do not have to worry about adding any data tied to what lens that you're using. That is automatically put in. And not only that, you'll notice it's grayed out here where you cannot physically change that. When you have this, one thing that we added about a year ago, a little over, well, about a year and a half now, is delta T indicator inside of the Q mode feature. And what that is that allows us to utilize this red boundary, in other words, showing that we are using this camera in an area that has a sufficient delta T to not only quantify, but in some cases, even visualize a leak. So it's a really nice understanding. I would leave the delta temperature at 2 degrees Celsius, but this is just, do you want the indicator on or would you like it off? In the software, as I mentioned, you would simply use the load button. You would touch the load button. You would find this, whether it's on a disk card or whether you want to put it and download it to your actual QL320 itself. You could find your file, open, simply tap open on the file, let it run 100% after it's complete. In other words, after you have 100% of this bar filled up, it will spit out and give you the number. In this case, this is that same one we looked at earlier that was 12,000 standard cubic centimeters per minute. When you do run that, what files are output? There will be 4 files output within your run QL. This is actually, should change. This is not an SCQ. This is called a DAT file now. This is the data file, which is what the QL320 recognizes as a file of interest. But you have your data file. You have a very simple and streamlined report. You have your raw video, which is a shortened video of leak, and then your plume overlay, which is once again a shortened video with the plume or any overlays that are turned on. In this case, I had the boundary overlay. You can see a little red dot here where I actually have the overlay of delta T as well as the plume overlay itself. So now you'll notice that even though it says that you can hear me from my computer, for those of you that are doing this, but you'll notice that you are now viewing the live screen of my QL320 itself. This is just a standard computer. Now I'm going to touch the Windows icon on the bottom, which allows me to see all of the normal applications that come with a Windows license that you would have in here. Google Chrome is what I'm in right now so that I can log into my personal email account and be able to log into my personal account and be able to utilize this GoToMeeting. You've got the QL320. I also have at the bottom here, I can pull up different folders. So this operates like any other standard computer. The difference is this is what you're going to see on your actual screen. You're going to have your QL320 application on the top left. You're going to have the quick start guide and your user's manual built into the desktop for easy access on the actual tablet itself. You'll see on the bottom right the serial number of your unit as well as the version that you have. If you have a FLIR QL320 with the black boundary and you have something less than version 1.4, to fix that, you would simply go to a Wi-Fi connection and hook this up to Wi-Fi. The tablet is made and set up once you're on Wi-Fi to go out there and check the actual connection and check the settings. You'll notice at the bottom left here, I have a little FLIR icon with an arrow pointing up, and that is simply telling me that it is looking for updates and it's consistently, and you can also force it to do this. This is telling me that I have done this, and I have the most recent. Now, if you connect this to Wi-Fi every time you come inside, the tablet will automatically do this on a consistent basis. So lastly, we'll just simply to access the application, I'm just going to touch it once, just like any icon. It's just going to highlight it. It doesn't know if I'm trying to change the name, what I'm trying to do. I'm going to double tap that icon on my screen. That's going to open your QL320. And it will take a couple seconds to pull up and load everything. This is what your QL320 will look like from the start. You'll have no video. The white box in the middle is simply telling me that I have nothing going on. All of the parameters are ready to be able to change, and they're looking for doing this. As FLIR salespeople and FLIR partners, the one thing that is a really unique tool that we demanded be in this solution is the ability for us to demo this either on site, or the idea of this was before COVID, where we could go into a conference room inside of a building without creating a massive leak that we can use and be able to demonstrate this. And that was a bit of a challenge in many cases of using the QL320. But now with demo mode, I simply tap demo and it begins pulling up information. These are sample videos that we can run through, and we can explore what's happening in these. I can show people how I can turn the plume overlay on and off, and I'll run through a couple of these here in a little bit. You'll notice as well that this isn't doing anything until on the bottom left, I touch measure. Now this is asking the tablet itself to process that file for between 5 and 10 seconds and run that video that is inside the demo folder and process that. In this case, this actual leak was approximately 22 standard liters per minute. It had a delta T of 16, which means that it had more than sufficient delta T to be able to accurately measure this. If I want to look at other scenarios, I can simply hit next. This is, as you can easily see, this is a great example of a white plume or an absorptive plume. Right now, there's not enough energy behind the plume to reach the detector, so the gas itself is sending energy into the detector to be able to be noticed as a leak. This is an actual, and I'm going to show you tomorrow when we go through some things and do a little bit more expansive training on the operation itself. But this is one of the files from a Q mode run that I did in the field. And you can even take some of your best Q mode files, put them into the QL320 demo feature, and turn them into a very, very easy to use demo feature. I like this one because it really highlights the difference between what a white plume and what happens if you take a white plume and call it a black plume. Now you'll notice very quickly and easily that I've backgrounded everything, and I've actually done this incorrectly, and I cannot measure anything. So I need to go back, and it'll go back to its white plume. The reason I realized this is that when I was in the field and I recorded this, I forgot to tell my Q mode file the most accurate plume color that we had. Now, every time I open the raw sequence file, which I will try to do tomorrow, every time I open the raw sequence file, it starts it off as a black plume, and I have to manually change that. And here's some other features that make it easy to use and understanding of what's happening within the QL. This is that same scenario. This is the one where I may want to show the plume, but in this case, this is the one that we'll talk a little bit about tomorrow. But I want to choose parts per million meters, and just to show you, I can put that box as small or as large as I want. I can make it cover the entire screen, which would have its challenges, or I can make it only cover the area that I might envision where the leak would be coming from. At this point in time, I could simply tap measure, and now it's running and processing that short 5 to 10 second clip from this leak to be able to find the maximum concentration reading within that clip, which is around 3,600 parts per million meters. Show you, this is another example of a demo file that I used with the Q mode and added it to the QL320. More demo files that are directly on here. This one's a little bit, I'm going to come in here and change this to other types of readings, but this is another just really small leak in standard liters per minute. This is another good example of the white plume with this would be also a good example of how and where to use a mask to be able to mask out the pipe that leak is coming out of. And the same thing with this one. When you're utilizing the camera, even though this leak is not a single point, because it's coming from a general area, this leak is easier for you. You would still utilize this as a point release. And the same thing, this is the one where I showed you earlier that I did 4 masking on this, and we'll get into some of those tomorrow. Looking at the time, the last thing I will just kind of go over on the left side with the user data, the things that you can do. I've shown you black and white plume. That does make this a little bit challenging, or a little bit, not challenging, but it makes it very evident when you have the wrong polarity in most scenarios. Your point types, you're going to have either point or diffused. Again, a diffused is when you have an extremely large leak that it may be coming out of let's say, a 1 foot or a 12-inch pipe, or if you're trying to look at a leak that might be not have a single point, something like a seal around a tank. The lens I cannot change even as I touch this. The distance, I would tell this how far away I am. What's the ambient air temperature where this leak is? So the ambient air temperature right where that component would be. The composition of methane, the wind speed at normal, and then the campaign is if I were saving this, I would want to be able to, if I were saving this, I would want to be able to maybe save it in a specific folder if I were using this tablet. The one thing, and we can get into some of the overlays, we're getting long in the day today, but we can get in some of the overlays tomorrow, some of the masking, how to do that within the camera, and then get back into the PowerPoint presentation to talk about some of the other advantages and maybe a little bit more in the weeds of the tips and tricks and some of the reports and studies that we've done within the quantification of optical gas imaging. One thing I will show you is if I come in here and just to give you an example, I want to, right now, this tablet does not know what kind of gas this is. So if I want to process this as a methane leak, it's going to be 21 liters per minute. But if I want to tell the unit that it is not a methane leak, is a propane leak, the number will change. And the reason for that is the intensity that this is understanding what's going on and how this video looks. The intensity of propane is so much greater than methane, the reading will go down because the gas that it's thinking is darker. It's lighter because this is actual methane as far as the gas intensity of each individual pixel. I'm telling this that it is supposed to be darker, and you'll notice that it's not linear. It didn't say, well, the other one was 21 and methane is 30%, so it really should be 7. You'll notice that I didn't change any parameters. It's a much more intuitive algorithm than just taking the response factor in a linear and saying this is 30% of this. Then it would be similar in that it would be 1/3 of the reading. So there is a lot happening inside of the algorithm that will change the reading consistently. On another scenario, if I were to change the actual delta T or the temperature, now I'm telling this that the temperature is different than what it was a minute ago. This was 21 liters per minute. The two challenges that you see here is one, that it brings in a lot of delta T. Again, I am just manipulating the QL320. This is not the actual accurate temperature. But I'm manipulating the QL320, so now you're going to have more interference on the piping itself, and it's going to change also the algorithm because I'm changing the intensity of the delta T in the background versus the ambient air temperature that I'm putting in. So I wanted to just show you that as you change this user data, as I change the parameters and the input numbers that I have, this changes a considerable more than just a linear number change of the factor. I want to also come in here and show you that there is internal understanding. There's different, and we'll show you a little bit tomorrow. There are different levels in distance that the algorithm begins to pull out. But in other words, it says that from certain distances, I make a circle a certain size. If I come in here at the original distance was 6 feet, so 2 meters, and I want to change that to 9 instead of I'm 1 meter further, I could go into 9, and you'll notice that the circle dramatically lowers and it gets smaller, because now this thinks that I'm further away, and in reality, this component would be much smaller in the screen if I were 33% or an extra meter away in this case. And the algorithm will also change. Instead of 21 or 22 standard liters per minute, it's thinking that I'm further away, so that leak looks bigger because the QL320 thinks that it is bigger, even though you're just closer to it. It's bigger, just as if I were to walk up to an object and stand 1 meter away, it would look big, but if I stand 5 meters away, that object looks smaller. We're running at the end of the time. Again, I wanted to give everybody a little exposure to the QL320. Tomorrow we'll probably start in the tablet itself and then go back to some of the features and the tips and tricks and some of the pieces of the software itself. Are there any questions today related to the operation, knowing that we're going to get into some of the other features, masking, overlays, units? Are there any questions that we can help you out with related to this QL320?
There are 2 questions, Craig. I'll read it out for you, and then you can decide how to give it today or tomorrow. So question number 1, what is the ideal distance and temperature for measurement? You have mentioned qualitative and quantitative analysis in one of the slides. Request if you can elaborate about.
Yeah, we will get into what I would define that as performance limitations of this. In other words, what the reality is, there's not really ideal, there's minimum and maximum. Yes, ideal would be if I were to look at these, there's not the ideal is you want to make sure it's not really a temperature for an ideal temperature. Ideally, the more delta T you have, the better optical gas imaging is. That's not just quantified optical gas imaging. The more delta T you have, the better that optical gas imaging will have, as an example, a minimum detectable leak range at exactly 0 delta T. In other words, if you're in a lab, the ambient air temperature is the exact same temperature as the background temperature. You will never see a leak, as big as it might be. Theoretically, you would absolutely never see that leak. In contrast, if you have a delta T of 20 degrees Celsius, you will see a much smaller leak in in that condition than you would at a delta T of 5. So there is a linear scale. I'm not going to get into that linear scale and all of that. So the ideal conditions are the greatest delta T. There are some competitors that when you start looking at specifications, they may not claim what specification delta T wise they use when they're providing minimum laboratory limits of their technology. If they use 20 delta T, they could actually very much skew, because it's not often that you're going to have a 20 degree delta T it's not always that you're going to have a 20 degree delta T in your environment. Distance wise, I would say that the distance wise is going to be just, the further away, the harder it is to use, the same as your eyesight. The further away, maybe I'm getting old, but the further away an object is, the harder it is for me to see it these days. So distance wise, I would probably say, from that 3 to 5 meters is probably optimal, but that's not necessary. We have made the corrections within the algorithms to be able to do that as accurately as possible. And then the wind speed, ideally a normal wind speed, a minimal 2 to 5 mile per hour wind speed is going to be the most ideal scenario that you would have. The other question is quantitative and qualitative analysis is one of the slides. Request if you can elaborate. Very simple. Quantitative is being able to give you a number. In other words, if I'm going to quantify a leak, this is 37 standard liters per minute. That is a quantitative analysis. Qualitative is not quantifying, it's just giving you the quality of the technology being used. That is a leak or that is not a leak. And I can look with the camera and be able to visually say qualitatively that that is a leak, because I can visually see the leak, but I would not be able to quantify the leak. Generally speaking, historically, OGI technology has been qualitative in its delivery. With the QL320 from FLIR, you now have the capability to take a qualitative analysis and make it quantitative. So I'm going to get into the unit. You'll notice that I have the QL320 loaded up and ready to go. And the first thing I usually do when I use this is make sure I can touch the demo feature and to be able to show the demo. The demos are selected because they're either common components, they are easy to understand, or they have pieces within them that are easy to train on and that are valuable. So as I look at this demo, the couple of things that I want to talk about. Yesterday we went over the full user data menu, from the polarity to the type of leak, distance, temperature, the gas compensation, or the primary gas compensation. Today I want to look at the actual other features outside of the user data. The first one we'll look at is the mask. In this case, you'll notice there at the bottom of the screen, you see a little bit of reflectivity off of that pipe, and that may make it a little bit challenging to get an accurate reading. And so what we can do to do that, to make this a little bit better, is what we define as mask out an area. So if you look at the top of the screen, you'll notice that it says mask off. That means whatever you look at and whatever words you read right now, those are the scenarios that are going to be happening on the QO unit as you're looking at it. So if I want to add a mask, I simply touch mask off. And the other thing you'll notice that the second that I touch that, it'll change colors to alert you that you have a mask and you might want to use that. So what I'm going to do now, the way that you add a mask is, while you can't see me doing this, on the screen, I'm using my finger, and you just swipe anywhere on that circle, which you'll see where I'm going to swipe on the left side of the circle where that valve wheel is. I'm going to swipe there, and then I'm going to swipe over through the circle to the bottom right. And this way I get out all of the pieces that I feel as you might want that might have error in there. You'll notice that the second circle that I swipe, I might have got a little bit too much off of there. I can simply touch remove last mask and swipe again. And now you can see that the edge of my circle is as close as I can really comfortably get to that pipe. And so that's how you can utilize the mask feature to get certain scenarios and areas out of your reading. I'm going to look at, you'll notice this one, the mask is still on. I can turn the mask off. And now in this reading would be an ideal mask, because you have a hard piece that has a delta T challenge, and sometimes you run into that piece moving in the wind. And this is the same scenario in this one, that this mask was on previously with this. But what I want to get to is an example where we may have multiple mask capabilities, and I showed you that, I believe, on a couple of scenarios, but this is a good one here. So now that I have my mask on, it's asking me to go ahead and install the mask. Because it's turned on, I'm going to swipe twice, and you're going to see me take out. But what I want to do now, instead of hit mask on or remove last mask, I just want to tap add mask. You couldn't see anything happen there, but now I'm going to swipe twice again, and I'm going to take that top gauge out of the scene. So you can add as many masks as you might want to when you're utilizing this technology. It makes it really, really unique, very good to be able to use this feature and to be able to ensure that you eliminate areas within the video that might produce an error. And sometimes that error is off of reflectivity. Sometimes that error is off of a pipe that might be moving in the wind a little bit, or maybe it's even the camera might be moving slightly, and this might help mask out the top of a tank. And some of those things that we're aware of, and we're looking at ways to streamline the technology to make it a little bit better and easier to use. The second piece that I want to kind of get into here are the overlays. I'm going to, the first overlay is the delta T overlay. The delta T is that background temperature that allows you to, it tells the technology to completely ignore whatever that background temperature might be. So on this one, I can turn the mask off, and you'll notice that this mask dramatically covers that. And you'll see the very edge of the tank kind of move a little bit. And that was just simply the fact that the camera was moving slightly in the wind. This one was actually on a manned lift. So the mask turned back on. If I turn that delta T overlay, it's not going to change my reading. And this is one thing I want to make sure people understand. The delta T overlay and what you see on there doesn't have any effect on the value of your reading, whether you have this on or off. It only affects the appearance. And the reason for the delta T overlay is so that when you're using the QL320 either in the field as you're tethered, or when you're processing a Q mode file after the fact, this delta T overlay makes it really unique and makes it easy to simply see where might I have delta T's? Do I have a delta T scenario where everything, my entire image is compromised with the temperature that we have? So really easy, really simple, basic, and easy to use. So I wanted to kind of show you that. The plume overlay again, doesn't have anything to do with the reading, but the plume overlay would allow you to see the black and white video that you would be, using. But the plume overlay just is for color presence. It makes it easier to see what's happening. Sometimes the black and white video is a bit of a challenge to understand. So in this case, anything that's moving in that screen, anything that is a gas or even a tag of some sort, you'll notice off of the opener piece of that level controller, you'll see a little tag hanging there. So that is also going to be highlighted in the plume overlay. Now, we talked a little bit yesterday about utilizing the concentration reading, and when you do the concentration reading, you have the capability to limit where that concentration reading is coming from. When you're doing a normal, whether it be mass or volume reading with the QL320, you want to ensure, and I'll show you some examples, you want to ensure that hanging tag never reaches the blue boundary. That's where you would have immense challenges with your reading and understanding, because the way that the camera or the way that the technology works is that the change in color has to move from the center out to the boundary. You always want to avoid tags, which we'll show you later, and that'll be my first, and to me, the most important tip and trick, and the biggest challenge that we've seen in the use of this in the field are people that just keep tags in the screen. So we have that capability you want to try to remove foreign objects that might be hanging in there. The last overlay is just the boundary, and that is going to be the blue circle. Some people don't like to see where the reading is happening from the center of the circle to the outer of the circle. I personally feel as though the boundary is key to understanding what's happening. And you'll notice yesterday that as I change the distance of how far away I am, it will dramatically change that boundary size. And that's telling the technology in the QL320 that I've moved further away. So that circle needs to be far further or smaller because that's the pixel to pixel movement, or the gas as it moves over distance, is going to be considerably different depending upon what camera, what lens in the scenario that I have there. The last one is the next one is the units. Again, this is something I could have done yesterday. I think most people on this call probably are more comfortable with metric units and meters and Celsius. So you'll notice on the left, my distance just changed from 5 to 1.5. It may not be exact. I think it's to a tenth of marker. So it changed from 5 to 1.5, and my temperature in Celsius changed to 13 for a 75 or so what it was. So once you add that, and now if I were to run the results, you would see the delta T is going to be in Celsius and not Fahrenheit. And all of the calculations, all the liters per minute, all of those are already in a set unit. And so it makes it super easy to use in how you're trying to process this. The next one is going to be the largest, probably the one that would be the most user dependent and the most unique, depending upon where you are, what customer you're talking to. It seems to me, in my experience over the last few years, everybody has a different way of doing it, in particular in regions. So the choices that we have for the variety of measurement units are going to be some of the mass, the volumetric, like cubic centimeters, mass, liters per minute. So you're going to have cubic centimeters per minute. You're going to have your concentration in parts per million meters, liters per minute, grams per hour, which is a standard of the United States EPA sensitivity standards for regulatory purposes, standard cubic foot per hour, which is commonly in the oil and gas industry, in particular in the States, called just SCUF. If you hear the word SCUF, it's standard cubic foot per hour. You also have SCUF per minute, standard cubic foot per minute, pounds per hour. You can even go to the point of megatons per hour, and there are people that like that large type. And if you think about in the way that you're using this, if you're using this over or for megatons per year, if you're using this over an annual scale, and you have a lot of readings, maybe those adding up of that megatons per year might be able to have a little bit more meaning in the long run. And then you have signal, and what signal would be is the processing signal that we're using to calculate this information and this data. And so I don't think anybody on this call would really use signal. The customer base that might use this is probably more of the scientific and academia customers that we have. And so I think that maybe 1%, if 1% of our customer base would have that. But it is in there because it's just the raw data, the signal, the processing signal within that, the raw data coming out of this. So not sure what this team is most. I believe we'll just start using standard cubic centimeters per minute, and as a processing number for our units. I'm going to skip over the modes. We've looked at the demo mode for right now, but I'll come into the modes here in a little bit. The next one is that auto plume, and the auto plume or manual plume. You'll notice that it says auto plume, and again, what you read is the way that the QL320 is working at that time. This last image is probably a pretty good one to utilize and to understand the auto plume versus manual plume, because there is a little bit of noise in this. So I'm going to touch this from auto plume, and I'm going to go down to manual plume, and you'll notice if I go to 5, the amount of colorized, and this is another huge advantage of the colorization, is that what is colorized, what you see in color, that's what the QL320 is trying to measure. And so if you go down and you change that manual sensitivity, down way to the left where I can see the leak coming out of my camera or on the QL tablet within the Q mode, but it's not being colorized. That's where you may want to do this. You'll notice as I go to about 8, 7 or 8, that's going to be that sweet spot for the technology. For the most part, I believe that when you use it in auto plume, it is somewhere between the 7 and 8. And when you store a Q mode file, it would be automatically set for an automatic plume at a sensitivity level of around 7 or 8. Again, now that it says manual plume and it's highlighted in blue, it is operating in a manual plume, and I'm just going to touch it. And when you go back to auto plume, it will choose the automatic plume in the level. I believe it'll choose the level that you have set. No, actually, it's going to go back, even though it says level 4 right there on the scale. That scale is grayed out, and that scale is not doing anything. That scale is just there as a backup reference for when you would change it to auto plume. But when you set it to or manual plume, when you set it to auto plume, it will go back to whatever number or whatever scale that the technology internally within the QL320 is trying to do. On the bottom, you'll see the information, and as we begin running some files, we'll run some Q mode files here. Now, unfortunately, I do not have a gas lab here in my office, and it would probably not be wise of me to just start popping up some propane and methane bottles here in my office. So unfortunately, I don't have a lab to be able to present from, so I will not be able to show you the live demonstration of how the unit would be tethered. But we will be able to run a fair amount of Q mode files. Now, I have some Q mode files from the field, and this is where you're gonna hear the ask from the BD guy at FLIR. As you use this technology, as you have customers that give you a Q mode file, or as you might be in the field doing a demonstration, and you are able to run on a tripod a Q mode file, and it is something of value, if it's interesting, those are great to share across the FLIR organization so that we can have better demonstrations. And I will also show you how you can take a Q mode file, process it, and if it's a really good video, you can take that video and put it into the demo folder of your QL320. As an example, this video right here is from a recording that I did out at a customer site. And so really good video, a good leak, and it helps to understand and process and show the capabilities of the QL320. So that now we'll go over to the modes. I will get into the results, measure and reset. Measure, just when you're in demo mode, measure just tells it to go ahead and process that approximately 10-second file here. If I change any of the user data or the mask information, it will actually begin processing it will change and update that information and set it back. The results back to 0 and rerun that as you saw. So again, process that. This is 41,000 standard cubic centimeters per minute. Now I can reset, I can save this information if I'd like. I can reset. You don't really have a need to save because you are in demo mode. Reset just sends it back to 0. So again, really easy to use in the demo mode. Now as we get into the other modes, the other one I will show you is going to be expert and normal mode. Now, expert mode is a unique mode within the QL320 that when you're in the field, it is going to give you a longer tail of data. And what I mean by that is, rather than 10 seconds of processing and then just giving you a number in a recording, it's going to give you a full 1 minute of processing and then allow you to record when that 1 minute and the 10 seconds have a certain variability or a certain standard deviation within each other. And when that happens, you saw just a minute ago that the save button highlights as red. When you are in expert mode tethered to a camera in the field, that save mode will turn green when you would like the capability, when you have a reading that the QL320 feels is pretty close to being accurate and within a standard deviation that's acceptable. Now, again, unfortunately, the expert mode is only able to be shown whenever you're in a lab or you're in the field where you have a reading that lasts upwards of a minute, and unfortunately, I do not have that within this demonstration today. But I would say that the majority of our customers, in my experience, they simply want a reading that is a good average over 10 seconds. And now you'll see that actually this is just looping this video file, and now it's actually pulling up and it's been looping. So you see the save button just turn red or green because the numbers are pretty consistent between the readings that I have between 1 minute and 10 seconds. And now that this is beginning to run and loop and start picking up some other, because there is some variability within that 10 seconds, now you can see how the expert mode works. But the easiest way to do a demonstration is to have some demo modes on file that are Q modes. So to load a Q mode, you would go into and simply touch the load mode, the top one there under the modes tab. Now from here, this is just the standard processing that you would have on a standard PC. I can simply touch the drop-down menu and choose what I want. If I had an SD card within this, I would potentially have a D drive, if you will. I would have the drive of either a USB stick where I have the SD card, or maybe I just have the micro SD card. So I could go directly to the micro SD card or the USB stick and pull this out. I will say that sometimes, in particular, when you're running 1 or 2 files, that works pretty well. But when you're trying to process, 5 or 10 file after file, and that card is pretty full, there isn't as much processing capabilities as the tablet or the computer that you're holding with a QL320 is running things off of the card. So it does work a little bit better if you have a full card to be able to pull some of the data that you would want. So what I'm going to do is just to show you, I have a folder here called QL320 training. In that, I have what I define as Q mode samples. I have lab or non-Q mode examples, and then the bad examples, which I'll get into last here. So I'm going to just open one of these lab or non-Q mode just to kind of show you what this is. And this is me running my lab here. This is when I say a lab, this is my driveway outdoors, shooting this from my garage with the camera. So I'm able to very quickly and run. This is a small leak at 32 standard liters per minute. If I want to say, you know what, I needed to see what another unit reading is in grams per hour, you do have to go back and reset that unit scenario. You have to reset the units and tell it to rerun on the bottom left. And so when I do that, you would just simply reset it, have it rerun, and you'll notice that this isn't a long file. Again, we're talking 5, maybe 10 seconds of processing. It's a 350 gram per hour leak, so this is just a bottle of propane. I've turned it up pretty heavily in a controlled outdoor lab just to kind of see the type of leak that I would get with that. You'll notice as well, a minute ago, I had the unit set in meters in Celsius. But when I recorded this video on my camera, I recorded this under feet in Fahrenheit. So when you load a Q mode or a previously recorded file, and I'm going to go back to my QL320. When you load one of those files, it will load it with the data that was recorded when you recorded the file or within the tethered QL, or when you recorded the Q mode information on there. Now you'll see two different files here. I'm just going to simply open black and white plume, and all of these are saved for a reason. And you'll notice when I open that, it's going to give me a unique file name called DAT. So I'm going to open that DAT file, and I'll explain what that means here in a minute. But this is a unique example of a pretty good leak at a test site. But this is a Q mode example of one where you have both black and white plume within one video. In other words, I have both emissive and absorptive characteristics within my scene. So you'll notice the red in the background is the sky, but the area of concern is more of the actual area on those vertical separators. So if I were to switch this over, and you'll notice this was 52 liters per minute, but just to show you, I'm going to rerun this in white plume, and because the temperature was set where it was, it's not going to show. So I'm going to change the temperature just to see if I can get an image shown. And now you can see the leak. The temperature is off a little bit, but you can see the link with the white plume in the background. And now, you know, the reading that you're going to get, a minute ago, it was 52 liters per minute, which was very close to the measured reading that we had within this data. But you can actually quickly and easily see all of this information, and now you can see what happens with the white plume. Generally, if you have a scenario like this, where you have both a white and a black plume, from what we have seen, the black plume works a little bit better with more accurate data. I guess the other rule of thumb might be you would want to, and I don't remember, I think it's 47. You would want to use whatever area probably has the leak crossing the boundary the most. So you'll notice in this case, you have a larger area of this circle in black plume where that leak is crossing the boundary. And so you'd want to use that as well as a rough guidance. But this is to show you that if there are scenarios where you have both white and black plume within the same temperature or within the same setting, you have that capability of using the technology pretty easily. And these are some call outs that you might want to see, and there's a reason that I've chosen these files that I'm going to go over today as demonstration files for a training purpose. I'm going to go into the next one. So that one, I went in and I ran the black and white plume. Now, one thing you'll notice this time, I simply chose the SEQ file, and I didn't go in and choose that very unique DAT file. The SEQ file is going to be the raw file that you get from the Q mode. So when you store the file in your camera, it's going to be a .seq, which is FLIR's naming for a radiometric image or a radiometric file. And so when you do that, it's going to create a folder that has those 4 pieces of data that I showed yesterday: your raw video, your colorized plume video, your report, and then also a process data file that the QL320 can operate and run with. Now I'll show you a couple of more of these. I'm just going to get into this delta T, and the reason I'm showing you this one is that shows you the importance. This one is one of those scenarios, excuse me, where the delta T is right on the edge of that 2 degrees of 2 degrees needed for that separation to ensure that the temperature and the delta T that you're looking at is appropriate enough for us to get, for the QL320 to get a good reading. So as this processes, I'll show you, it'll give me my reading in liters per minute, and then it will also give me a delta T of 3.4. Now, if I simply take this delta T and change it by 2 degrees, it was 38. I'm going to see if I just change it to, yeah, if I take it from 38, just 2 degrees, now you'll notice a 2-degree change dramatically changed how much delta T there is within this. Now, if I didn't have this overlay on, I really wouldn't know where I have problems, even though they are, the colorization of the plume is going to always be eliminated by the delta T. But this is just to show you that probably the most accurate that you need to be in understanding this is that delta T, or that ambient air condition, air temperature around that component, because even a small measure of changing a degree or two can have a pretty dramatic effect of the reading. This one I call good, mask lower. This one, and the reason I call that, this is a good example of where you might want to have a mask on the lower portion of a reading, or a lower portion of this. You'll notice on this video, and this is also one of the demo videos that I have, you'll notice on the video that you can start to see a little interference within the bottom of that, with maybe some grass rolling in the background that is moving. And so the great thing about this is you want to try to find the right angle that is on the edge, or if you can, outside of your screen. So this says that it's 39 liters per minute. And now I'm simply going to take this one, and hit rerun. Now you'll notice I can take out a lot of that. All I need is the area of that circle where the gas plume is crossing. So there's a lot of that interference. I can easily take that out. And as long as I have the area where the gas plume is crossing over there, a second ago this result was 39 standard liters per minute. Now it should go down a little bit because you do not have the interference. So the more true and accurate reading of this would be around 23 standard liters per minute, because I have removed all of the interference that you can see on the bottom of the screen there. So really a great unique feature, and this is a good example of showing that that capability of running something with a mask on. I have one here called mask left side. I'm just going to open the SEQ file. One thing that I need to inform the engineers is, when you're running a file, if you continually try to reopen a lot of files before you give the previous file a chance to run, that does sometimes have the ability for the technology or the unit to not quite understand what's going on, or how to process that. So I usually always recommend trying to allow a file to completely run. But I'm going to run this mask left side. This is going to be very similar to the one that we previously saw. In this case, I've got some interference there on the left side, but because the leak that I'm looking at is dramatically moving from left to right, it never crosses the right boundary. I don't have to only mask off just that little bit of the left side. I can mask off everything that doesn't apply to this, because there is more interference on the left with the grass slightly moving and the delta T background in the top with the sky. All that I care about, all that I need to understand, is the area where that gas boundary crosses the circle. And so you have the capabilities to very quickly and easily look at that and be able to see what's happening with respect to the leak at hand. And now a 6.5 liters per minute, a pretty small leak, and it would have been considerably larger if the equation and the calibration were using some of the errant data from the kind of ocean of grass in the background that has some of that. So they have put these masking capabilities that make this so much easier to get a better delta T and a better reading and more accurate reading. And one of the last ones I have here in the Q mode is going to be the color polarity. I showed you this. This is also one of the ones that we would use. But one thing I like to show you is as this file is running, I can change these overlays on and off without resetting the results, without resetting the unit or the calculations that are being run in the background. If I change a mask or any user data, that is where you would run into an area where you have the process or the sequence or the run, as they call it, would reset. So this was a much larger leak, 90 liters per minute compared to the previous one. But one thing I will show you is that you do have on the bottom of the screen, in that black box, we'll have the result of this run that I just did, the file that I used, and the result of the previous run that you want. So that way, if I were to change some user data parameters, I can easily get the result of a previous file that was run and make it easier to use. And the last thing, I want to pull one of these readings, and I'll just pull up my lab here. Hit open, lab, and I want to show you the different units. In this case, I want to show you the parts per million meters. And we showed you this a little bit yesterday with respect to how to do this. But all I need to do here is I want to try, even though I have some interference in that background, that doesn't matter with the parts per million because it's not taking all of the data in. When you're using your concentration or your parts per million meter concentration over path length reading, it is only taking the maximum of what's happening within there. So the maximum in this video was 14,000 parts per million meters. What I'm going to show you now is I want to rerun this, and I simply want to put this box really small and over the actual output, and probably the highest concentration of that leak is going to be very close to where you would have that reading within the output of the leak. So this is processing now. The last one was 14,000 parts per million over a meter path length. And when this gets done processing, the number should be the same, and yes, it is, 14,000 parts per million meters, because I'm only pulling the maximum reading, or when I talk about this, the maximum signal intensity of those pixels within that area. One other thing I'm going to do here is now I want to actually just pull this off a little bit. This might be a little bit lower because I'm not getting the maximum area of where that's coming out. This could be, it's pretty close, so it could be pretty similar, but you can see that I'm a little bit off the output. And the good thing about the concentration readings, parts per million meters, is that you can adjust for any foreign objects. It's the only way to use this technology effectively. If there are foreign objects within the screen that make it more challenging to use. So this one again, 14,000. And I don't know if I haven't tested this, but I could even come out here and say, what's the maximum concentration as this is moving further and further away? This may be similar because it's a very consistent flow. As this is a lab, it is a consistent output within that point release. And as that consistent output is not just consistent in the amount, but the direction that it's moving is very, very, very consistent from the right to left and almost straight to the left. So there may be a little bit of a fall off, as you can see, from 14,000 to 8,000 parts per million, because I've gone further away from the actual point release. Now that I've shown you some of the good ways to do this, I do want to show you a couple of bad things. I have what I define are bad examples. This is going to lead us into the presentation, and I'm going to show you a couple of things there. But my first bad example, you've heard me talk about it. This was a video sent to me by a customer, and it's hard to see because of the plume, but if I turn the plume off, you'll notice there's just a tag hanging and flying all around inside of that level controller, just like the one that I showed you a minute ago in the demo mode. But that level controller, at that time, the tag never reached the boundary. In this case, you notice all of the leak. The only thing that the QL320 is trying to recognize is that tag, and it's only trying to recognize the movement of that tag because it sees it moving from the center to the boundary. Keeping in mind whether it is a tag, whether it is sometimes clouds, whether it's tall grass that might be moving, you do need to be cognizant or understanding of the technology that we're just looking at moving pixels, whether it's something moving by behind it or whether it's a scenario where you have a tag or something, you know, a windsock above a tank. If you get stuff like that within the view, in particular within your field of view, where that object, what I define as a foreign object, crosses the blue boundary, is where you're going to really run into some challenges. Another one is what happens when you don't use the unit on a tripod. And I've had customers that came out to me and said, well, I thought I was holding it pretty still. I tried to lean against the truck and make sure that I didn't move. And this was from a customer that did that. And you'll notice, I'm going to turn the Delta T off. You'll notice the amount of gas that's coming out there. And the camera itself, or the unit itself, cannot measure that because of the movement. The only thing it's trying to measure is the movement on the tops of those buildings because the camera sees the tops of those buildings as the camera is slightly moving. The camera sees that as a dramatic change. So you can easily look at this and say, wow, this is really an evident leak. The other issue with this is an evident point release, and ideally you would want that to be as close to the center of the screen as possible. But even the smallest amount of movements, if you think that you're holding it super steady because you got strong hands, it's really, really challenging to do that in the way the technology is developed today. And lastly, I'm going to open one more bad example, and I'm going to show you a couple of things. And this is one where you may have clouds in the background. Now, this looks pretty good. It looks like you know what's happening here. But you'll notice that the plume colorization begins to pull in some of the Delta T. And right now, I've defined this as a white plume because realistically, it is white as long as there's black or less temperature, and when it's white, whenever it's an emissive plume. But when that leak runs over the clouds, it begins to turn to a black plume. And there's really no way to make this happen and make this run effectively. So you need, with getting an accurate reading, when you have these slow moving, intermittent in and out clouds in the background. If this was completely cloudy, with the clouds barely moving and or not, you know, slightly moving, you could probably make this happen because the clouds would work as a warmer background. They're absorbing it, they're holding the atmospheric energy in, and they would work, and this would be an emissive plume. But as you an absorptive plume, but as or if it's all open sky with no cloud, then you would actually run into a scenario where you have a white plume or an absorptive plume. So I want you to understand that these are more of call outs so that you understand when you're using this. Now within the QL320 or in the GF320 or X320, we have the delta T capabilities, and you can easily see when I run this, you can easily see the delta T on and off and the challenges that you would have. And you can see that whether you're in a white plume or a black plume. So again, this is more of an awareness scenario that if you have situations like this, you want to try to find a better angle, if possible, to be able to view this leak. The last thing I wanted to show you is two things. One, I'm just going to go into the QL320 here. Now, I don't have Q mode activated, but I want to show you what a file looks like before you do anything. So a lot of this this is called Q mode files. If you just pull over Q mode files, this is all that they look like. Your screen would look like this. This is just the file directly from the camera, SEQ _ whatever number file name that is, .SEQ. And once you process that in your QL320, you create this folder, SEQ _ the file name, and then you're going to have these 4 data points. You're going to have the raw video, you're going to have the plume video, you're going to have a PDF, which is that report, and you're going to have the SEQ, the actual data file that is processed within this. So again, this is what it would look like. So you can go into any of these and change the name. So as an example, I want to show you if if we had a Q mode file and I went in and I opened it, I processed it, and I ran it. In this case, I'm just going to choose sequence 0091. If I processed that and I ran that and I liked it, and I thought, man, this would be something that I would want to put on my demo function, I can simply go in here and hit copy. And then you could go into your PC, my C drive, and these are going to be the files from the QL320. The archive file is where you would store all of the previous data. If you go run this tethered, it saves everything in the archive. But I could come into demo and actually just paste that file, and now I have sequence 0091, and I can also go in here and change the name of sequence 0091 just to test or training. And so now I actually have an additional Q mode file that I've set as a demo file. So when I run through the demos, you would actually be able to now have that as one of your selected demonstrations. So again, it's really easy to use, super intuitive to be able to take a recorded Q mode file and transfer it over as a demo. So yeah, now I want to kind of go into some of those tips and tricks. And we talked about a number of these when we were doing the live demonstration. But these are some pretty good examples. These are videos or screenshots from customers that actually sent me and said, your technology really doesn't work very well. In this case, or this scenario, you can see a hanging LDAR tag off of a component. This I don't think is the exact visual to match this OGI scenario, but you can see the blue is where the technology believes that it started. The white is where that tag is. So you can easily see as that tag is moving, it's going from inside the circle to outside the circle. This had an error of over 22,000 is how high the reading was. But the only reading is that it was extremely windy with that tag. So the number one call out, in my opinion, the number one tip is don't ever use this when there is a foreign object like an LDAR tag or a marker that might be like a little orange marker to mark where this leak is. That becomes a challenge in trying to quantify this leak. Here's the actual video of that leak, and you can see that the tag goes left, it goes right, and the full video was this tag moving all over the place. The produced video with the plume overlay is only a couple of seconds and not the full 10 seconds that you would have in your QL320 data. So again, this is the number one call out. The second one is stability is a must. You must use this camera on a tripod, and that is because we're watching pixels move from point A to point B, from the center of a circle to the outside of a circle. And so when you're using this as steady as you feel you might be, you do need to use this on a tripod. And that is even for Q mode. If you're using this and you want to save a Q mode file and process it after the fact, in that case, the Q mode file must be recorded with the camera on a tripod as well. I showed you this video, and again, even though this video looks, and you can see the windsock in the background, and even though the video looks like it's barely moving, and this gentleman that recorded this said, hey, I thought I was steady enough. You really need to kind of record these on a tripod. As we talked about in the thing, delta T matters a lot. And then we look at the QOGI triangle, which I don't know if we got into that in this presentation, but the delta T, of 2 degrees Celsius is required, and you need to ensure that that delta T that you have. And luckily, in both the Q mode feature as well as the tethered unit, we've added a colorization background supplement to allow you to see if you don't have sufficient 2 degrees delta T, in which case you may need to adjust some of the settings either in the tablet and the camera, or try to find a better angle to be able to look at. In this case, this is one of the videos that I showed you in the demonstration. The actual reading was 32 liters per minute from the metered valve. Whenever I had the accurate delta T, in this reading, I had 34 liters per minute, so almost spot on for what the actual or metered reading was. As I changed the delta T simply by 2 degrees, it changed from 34 to 45 liters per minute, dramatically changing my input. So again, ensuring that you get the most accurate delta T is quite important when you're utilizing this and you're running this program. When you're using the mass and volume, and I showed you the video that didn't work very well with an unsteady, non-tripod use of the camera, where the actual vent was off the center. But when you're using this in mass or volumetric readings, you do want to ensure and try to do what you can to make sure that the point release, where that leak is coming out, is in the center of your screen. That way you can have the most area traveled from the point release to the circle and get as much information inside of the quantification algorithm as you can. And the last one, these parameters, we've talked about the temperature, but all the parameters information is key. Understanding delta T, the distance, what polarity you have. If you have the wrong polarity, Luckily, you can fix that in the tablet, but it begins challenging to use in the field. And here's a case where we had an actual leak of 60 liters per minute. When I used the correct polarity or incorrect polarity, it said it was 4 liters per minute on the right. But when I used the correct polarity, it told me it was 56 liters per minute. So ensuring that you put the right polarity, this shows how dramatically that can affect this. It can also happen the other direction. So I have a leak, 16 liters per minute leak. As I have the correct polarity or the black plume, I have an 18 liters per minute leak, but with the incorrect polarity, it just removes. And you'll notice if you have it incorrect with a lot of delta T in the background, the reading will always be low because it is removing all of those pixels from consideration. Understanding the limitations, again, we've talked about delta T, it needs to be 2 degrees. The distance that we would need to use this is somewhat dependent of which lens you have. If you have a standard lens on your camera, you would be able to use this from 5 to 54 feet. I apologize, I don't have this in meters. But if you have the 6-degree lens, the 92mm lens, you can use this algorithm and technology up to 210 feet away. So you can use the QL320 with the full array of lenses. Another big question that we get is what is the minimum and maximum leak detection? And that depends upon the release geometry. In other words, the size of the leak, in other words, where the leak is coming out. Generally, these leaks are usually coming out of a small geometry. The point release up to around a ½ inch to an inch of release geometry in which you would want to use point release. That it would operate and it would be calibrated from around 0.2 liters per minute up to around 40 liters per minute. And you'll notice there's different calibrations. When you change this, the circle size, it does recommend, it does acknowledge what number you put in at distance, and there are different linear calculations in the algorithm that adjust for that. If you have an extremely large release geometry, up to 10 or 12 inches, you actually have the ability to measure something at up to around 300 liters per minute of methane, which is a pretty large leak. In that we're looking, we're continually looking at the technology on how we might be able to expand that. I've talked about this in the training, but understanding the conditions of white plume versus black plume, understanding that there are environmental conditions in which it makes it extremely challenging. In this case, you can see that the calculations are recording the clouds and not the leak. So just need to understand those environmental conditions as well as possible. I do want to go into the validation studies. There are 3 validations. 2 of these are public. One of these is from FLIR. The first one is in Europe called QOGI. It's the longest, the oldest validation study we have. This study was performed with the first generation of QOGI, which means that we have dramatically updated the technology, the algorithm, and everything, and how this operates. I won't get into this too much other than the output. The key output from this study was the actual average standard deviation, the difference, the average difference with the QOGI. On average, we had a 6% error or a 6% difference between the known emissions and what we measured. A sniffer, which is the gold star, a toxic vapor analyzer in quantification, even telling the sniffer where to go, the sniffer had an estimation and an average difference of 155%. I'm not sorry, 31%. I'm looking at the wrong line. So if you think about that, from 6% to 31, we were over 5 times better than a sniffer, and even telling a sniffer where to go. Another one that's more recent is a study called the AMFC study. This is in June of 2020. And what this was is this was a field trial in Canada. And this was done by scholars and academia as well as industry experts. The long story of this is the result output, or this technology was used to evaluate other defined as new technologies in the methane mitigation world. The result output was that the QL320 had significantly better information as long as you're using it in what is defined as aggregate methane emissions. And what we mean by that is on an individual basis, these readings were not, these readings weren't all on this direct line. This dotted line is where you'd want them to be. On an individual basis, they were not all on the dotted line. But as you take the full readings, as you take more and more readings, the more accurate this gets. Compared to a high flow sampler, which for mass and volume readings is the gold standard globally from a company called Bacharach, who no longer makes the device, we had an aggregate error of around 18% compared to an aggregate error on other high flow sampler testing of around 10%. Great. So, it was a really great thing, and that is a public study online. We also did a personal study at the METEC Methane Emissions Testing Evaluation Center, where we did over 80 QL320 evaluation data sets. Many of the videos I showed you from today were from this. The result of this was that over these 80 data sets, we had the exact same result as we did in the AMFC Canadian study. Over an 80 data set, our aggregate error, again, the dots are high and the dots are low, but the more data that you have to compile, in other words, over a certain amount of time, over a basin, over a region, we had an aggregate error of 4% running that data. Extremely, extremely valuable things. And the reason for running this test was to try and evaluate and try to understand, did that Canadian test, was it a fluke or was it accurate in the estimation that over aggregate data, the QL320 provides consistent and positive results. Lastly, we have this last session is where can I go get some more information? First off, this will be recorded and we'll have this training video available through your FLIR manager. We do have a FLIR QL320 product page, which has some data. It has the RF factors, in other words, the response factors at the bottom of that with the supporting material on that. We have a new QL320 training page. I'll show you a quick video here in a second, where we've actually taken a lot of what I did today in short, under 2-minute videos with one of our professionals and allowed them to do a quick and easy training. If you need help, we have request help. I showed you yesterday the quick start guide, and again, very simple, quickstart.ql320.com. We have some pre-recording training webinars that are much more technical than what we're doing today. And then we also have some white papers on the top 10 questions and understanding the basics of QOGI, more of a linear form for you to share with your customers of what we went over in these last couple of days. The new training video website, again, there are trainings on setup, on masks and overlays, the various features, measurements, functions, Q mode, quantification, and tips and tricks. Again, there's, I believe, about 10 or 15 videos. I think I may even have a sample of one of these videos.
Hello, this is Mark Fishburne with the FLIR gas detection team, and we're here today to talk about the FLIR QL320 and the basic startup of the tablet. I'm going to do clockwise on this session, and the power button is here in the 11 o'clock position. You'll notice that after I hit the power button that we have a power up here and the battery green light here. If the battery was to be run down, you would notice it quick, it would start to go red. On the top of the tablet, we have a hand mount with 2 points on the end here.
So I won't go through that whole thing, but we do have a number of videos to try to help you and our customers get acclimated and understanding. You can use these both pre-sale and post-sale to try to help drive awareness of the technology. This is an example of the white paper that we have. These are the 10 questions that were asked in the white paper that we wrote to be able to try to help educate people with the common call outs that we may have. And